imaging of a carbon-filled PETG component. Core XY. Our large studio printer. Actually, interesting. You can actually see the heat reflection or heat gain on the top of the aluminum plate under the bed there from radiant heat. But this is with a Hemera extruder. There. With a Volcano E3D hot end running a nozzle X 0.8 millimeter for this particular print. We basically converted this one based on the large size of the print of this printer that we offer. Pretty much run exclusively with the Volcano nozzle. It can go down to 0.4 as well. Sorry about that. And right now it's featuring a Hemera extruder setup here, and this is a 40-20 fan on the side with ducting down to here for part cooling, though that will likely change in our more final units to be a 1550, the one that's featured on our smaller printer, also Core XY, and we'll share some information about that and a good look into the clear duct work that goes into the part cooling part of things on the printer there. This one will soon be getting that upgrade as well, with part cooling made instead of out of a PETG print. It's going to be made professionally, injection molded, or through other processes that give it a perfected airflow, 360 degree, that just comes right down to the nozzle tip where you need it to be. Anyway, this is very large printer here, as you can see. Let's see if we can back up enough. On top here, it's got this little lobe here. That's a Nest camera. You can see the belting for the Core XY. It's about 700 or so by 700 by 330 this way. So that's just the internal bed. The external frame is larger. Coming out to about here, you can see my imparting. See if you can see any of the. Sometimes the body heat will reflect off of that. Some of our machine work there. Anyway, this is just a very good all-around part to show an example of. It's very nice, functional part for an end-use user. That will actually be the final model. Other things here, since this sensor or touchless homing with optical sensors and or inductive Z probe. Well, that's not the actual probe that goes on the end. That's just a limit switch. It's an inductive limit switch, and then we have optical limit switches on the X and Y. Right now we're looking at this for our A and B motors that we have here, looking into the temperatures that we're getting while running them, to see if we would like to consider putting a Noctua or other very silent brand of fan. I actually have a perfect one in mind that I know makes absolutely no noise at all, that could help. These are just being set on there for the testing purposes. These heat sinks. You can see that's a NEMA 17. It's running at I can't remember the amperage right now if it go into configs, but it's at its rated amperage, And then, of course, this we expect to be a little warm here because this that I'm about to show you is the Z-axis. Very, very large, high torque motor, as it has to through a belted system that keeps the lead screws in unison with one motor. It has to lift this very, very heavy bed. So we've gone with a very high torque motor on this, and of course it doesn't seem to have a need for our intervention to cool it down, although it does have a aluminum heat sink as well. It's just at the full size one. It actually has a little hole for venting in the top and attachment points there and there, just various things. We're just looking around here. Electronics box will be moved in the final versions, release versions. Anyway, I'm going to get some regular video of this part so you can see it. It is really nice to see how much temperature is being placed between each layer. They're really forming strong bonds there. This is a engineering quality filament being used for a structural part. Let me swap over to a normal camera view. Look at that. Look at that heat you get there. Great layer bondage. Wonderful. Just wonderful.